various types of quadrilateral. Now comes to proving out different theorems basing on quadrilaterals. Let's start. Already I have told you about the types of quadrilateral. We are going to start with the theorems now regarding the quadrilateral. The first theorem, 8.1, a diagonal of a parallelogram divides it into two congruent triangles. Now whenever you go to prove a theorem, first you have to conclude from the given statement what all given and what to prove. So the first part, we have to draw the figure. Let's draw a parallelogram, name it, draw the diagonal. Now according to the properties of a parallelogram, we have to give the symbols on the parallelogram. Now this angle, opposite angles are equal. Now if this side is equal to this side, this is equal to this and this is parallel to this, whereas this is parallel to this. Give the symbols first and then mark the angles. As I have already marked, this angle equal to this, the whole angle equal to whole angle, but when we have drawn the diagonal, it exactly may or may not divide into two equal angles. But if this is a parallel line to this acts as a transversal, then this angle will be equal to this angle. And the rest of the angle of this will be equal to this. From the given statement now, conclude what all given. First step, write down given. AB is equal to CD. You can write like this because they are line segments. You can give marks on this also, comma. AD also equals to BC. What comes next? This is the first given point. Second given point is AB is parallel to CD and AD is parallel to BC. Now what to prove? Next step is to prove. Whatever given from the statement you have noted down. Now what to prove? Basing on that you have to note down. What are we going to prove now? From the figure with the names you have to note down. Triangle ABD is congruent to triangle. Now can I write any way I like for the triangle BCD? No. Whenever the question of congruency comes, we have to name the sequence of the triangle. If AB I have written, here it will be CD, then comes D, ABD, then I will write CDB. Triangle CDB. To prove two triangles to be similar, we have to go for SSS, SAS or ASA. What do we find in these triangles? We find AD. Now start proof. The step you have to mention proof. AD of triangle ABD is equal to BC of triangle CDB. Then comes here, first of all, let me show you in these two triangles, we find all the three angles to be equal. Here I want to make you clear, if three angles are equal of two triangles, they may be congruent, may not be, but they are called similar triangles. Here our aim is to prove as congruent triangles. So we have to go for SSS or SAS, ASA. Here what is easy for us? It will be SAS. Now this side equal to this side equal to this side, and the included angle are also equal. Then write down the other side. AB is equal to CD. And then comes your, within these two sides, equal sides, the included angle comes to be DAB. Is, if I take DAB, I have to take BCD. Angle BCD. What are we going to conclude now? Triangle, hence triangle ABD is congruent to triangle CDB. Why? The reason you have to write ASA. Hence proved. So can we write ASA though it is fitting here? No. Then what criteria? SAS. So students, it can be, particularly this theorem can be proved by any criteria. SSS, ASA or SAS. For other theorems, it may not be equally applicable. This is a typical theorem which fits for any criteria, because this diagonal is same for both the triangles, opposite sides are equal, hence SAS is satisfied. Then ASA, these two angles equal to these two, included side equal. But we have taken this side equal to this side equal to this side, and the included angle to be equal. So thank you children.